Hello, everyone, and welcome to Applicative Programming. So we're going to unpack like this map filter, reducey kind of thing that we've been doing since the very beginning of the program. Hey, Will's here. We're going to unpack this map filter, reduce, find, sort kind of idea. We're going to go one level deeper in that and start to understand really how these things work. So, oops, I should get my whiteboard. So the broad idea of applicative programming is actually pretty simple. You have some kind of collection of things, and you are applying a function to each one of them. That's why it's called applicative. It's about applying a function. In practice, that we can make some of the most complicated structures in programming this way. So, thing to boot up. There we go. I hope that each and every one of you will be able to code an applicative function from scratch by the end of this lesson. So let's start with map. Map's a good one. So what does a map do, generally speaking?
It returns a, I guess what's the word I want to use here, like a mutated array from the original array that you like passed to it, and that mutation is dependent on what you were trying to do through the map. That's
yes.
best I got.
Very good. I'm going to use the word transform instead of mutate. Mutate means something slightly different, but like in regular English, yes, that's exactly what it does. Turns a transformed, and I'm also going to say collection, because in JavaScript, we generally expect to do this with arrays. In Ruby, we could do it with arrays or hashes. And lots of other language, it's less picky about what your collection is, so long as it's some collection. So it returns a transformed collection. Cool. So that's what a map does. What if we didn't have map? What if it wasn't built into the language? God forbid. How could we make a map?
You'd have to write a for loop.
Yeah, we could do it with a for loop. So if I have some function called map, we're probably going to have some kind of loop in here. What is that map function going to need?
Empty array.
Not necessarily an empty, well, like up here. So we'll call this like transformed array.
Yeah, you'd have to have somewhere to store this new data.
Yeah. So we'll have our transformed array. What gets passed into it?
Another function.
Yeah, so we got to have a function that we're going to apply. And then what's the other thing we need?
The original array.
Yeah, we need the data. So we need the data, and we need a function that we want to do on everything in that data. And so then here's where the magic happens. We're going to call that function every single time on everything in this data. All right, so I'm going to do this one. I'm going to do map. I want you to just watch. We'll do some other ones together. All right, nothing up this sleeve, nothing up this sleeve. I make, actually, I'm just going to call it, yeah, that's fine. So I'm going to make a function called map that takes in, we'll call it an array, and a function. Note, I can't use the word function. Why?
Because it's input. It's a call. It's a label.
Yeah. So our vocab word for that would be reserved word.
Yeah.
It's already being used by the language. So we can say fn. We can say like function to apply if we want to be a little bit more verbose. Okay, and then we had our transformed array. And we want to return that transformed array. And so the magic happens in the middle. So let's say, I'll do this with a for loop. I'll do it with a for, we'll do it with for n. So we'll say for index in array. So we'll say that the item is array at index. Then what's the thing that I want to do?
Call the function for each of the items.
Yeah. So I'll do function to apply. I'm going to apply it to item. And then what do I want to do with the result of that?
Return.
Mm,
Oh, no. Sorry, push it into the transformed array.
yeah. Cool. I wonder if it works. So if I make a function called double, and it returns some number times 2, and I have an array of numbers, and I want to map over the numbers and make it show and make it double each of them. I could do map that needs numbers and double. I wonder if it works. We just made a map from scratch. That's the idea. We are applying a function that we were given. We don't know what the function is ahead of time. Kind of doesn't matter. It gets applied to every item in the collection. Ask me some questions about this.
Where does so where do these outside of this idea of with enumerables, where else in, I guess, in JavaScript are we going to be using this kind of ideas of the callback function and applicatives?
Sure. So you'll hear people call these things callback functions all the time. It's probably even in the curriculum somewhere. These are technically not callback functions. Callback functions are specifically in response to an asynchronous thing. This, like more properly, is just a higher order function. But you'll hear people call them callbacks. So to answer your question more directly, we use it with map, we use it with filter, we use it with reduce. We also use it with find. We also use it with sort. We also use it with some things that aren't built into the language, but are really common, like pick. Pick is, all right, I have this array of objects. I want the following 3 properties from all of the objects. So I want a new array with some smaller object in all of them. Or like the other way around. I have an array of objects. I want you to drop the ID property from every one of them. That's called an omit. It's another really common use of applicative programming. Actually, I was looking at my notes before this and I found, there you go. Those are, it's a pretty good collection of common applicative functions. Other questions about how this works? Cool. Without looking at my example, I want you to see if you can do that map from scratch. We'll play around with some of the other ones too, but see if you can do the thing that I just did on your own. So I'm going to give it, start with 4 minutes. Go. Make a map on your own. Same thing I just did. Oh, there's suddenly a shit ton of you here. I thought there were still 3 people.
Ahmed's class ran a little over.
I see. All right, so pencils down. Give me a fist of 5. Fist is, I have no idea what we're supposed to be doing. 5 is, I got a working map. Okay, cool. Lots of fists. So were you coming in late? Did you like come in after we started the activity or something? All right, cool.
Yeah, we did.
Got it. So let's go back a little bit. So we're talking about how, like, if map didn't exist, what would we do to make it? So we talked about how we would have a function called map. It takes in some data we're transforming. It has a function that we are applying to everything in this collection. And so then we did an implementation of, oops, I'm not screen sharing. So then I did an implementation of it here where we take in an array, we take in a function that we're applying to everything in the array. This is the thing that we're eventually going to return. We loop through everything in the array, we pull out the item, and here's the killer part. We pass that item into the function we were given. We don't know what that function is going to be. It could be double, it could be turn this into an object, it could be turn this into a Pokemon. Maybe these are all IDs. We don't know what it is. We don't care. The shape is still the same of it. We call that function with the item, and we take the result and push it into this array. That's applicative programming. Ask me some questions about that.
Okay, so for the, like in line 2,
Mhm.
for
Here, I'll take out the relative numbers. Which line?
for index in array, line 4, you're saying for every index in that array, you are setting it equal to an item?
I'm pulling out whatever the thing is. So like in this array, the indexes of this are 0, 1, 2, 3, 4.
Yeah.
Oh, the actual values in there. And so I'm pulling out those values here.
Ah, okay. Thank you.
Is index in array like an actual like common argument that you can use in for loops in JavaScript?
As of 2015, let's see when foreign got added. Can I use foreign? Oops, no, I don't want that. I don't want can I use. I want Kengax. All right, let's see where for of got added in 2015. I think for in is older than that. So a couple different ways we can write for loops. I could have written this like that is the classic C style for loop. I could have also done actually I should have put a let on that also. Let item of array And now I can get the value of it directly, or I can get the index. All three of these are legal in JavaScript. And all three of them are pretty common in most programming languages, FYI. So I could have done that. Works exactly the same. Other questions so far? So one of the cool things that we can do with this function we're applying is this shape is what a map is. That function can be arbitrarily complex. Like this one is just doubling a number. Let's say instead of that, we got like an array of objects. And let's say I want to make all of those loud names have exclamation points on the end of them. So I could make a function called loudify that takes in some object and returns some object dot name, put a template string. Cool, that's all it does. Now I could take some array of objects, pass in loudify to it, and what does it do? Transforms all of our things. So it went from doubling an array of numbers to transforming an array of objects. Map doesn't care what the transformation is. The shape of a map is the same every time. We're still just applying an arbitrary function to it. Questions before we move on? All right, new challenge. So I want you to code up a filter. A little bit different. As a reminder, a filter that takes in a specific kind of function. Well, first, let's talk, what is a filter generally? What's it supposed to do?
Apply a condition to
up from that, like what is the result of filtering something?
a new array based on a condition.
New array based on a condition. Any other aspects to filter in particular?
Where the condition is true.
Yeah. Where the condition is true. So the kind of function that we pass into a filter is specifically, here, for my note. called a predicate. Predicate is a function that returns true or false. We're still sharing. Predicate is a function that returns true or false. So we need something that returns true or false. We want a new array that's everything that function returned true for. So if you want an example, let's go with, we'll have an array with Kyle and Christine. And you want to filter this only people only 4 or fewer characters. So I want you to write a filter function that can do this. Questions? All right, give it a shot. Go. All right. So follow-up question. Fist to 5. Fist is, I don't know what we're supposed to be doing still. 5 is, I got to work and filter. Cool. Very nice. Thank you. So let's talk through it together.
I don't know how to check to see if it works.
Oh, so real quick, like node crash course. If you just make some file and give it a JS extension, and you put something in there like console.log hi, and then just type node and that file, it runs the file. So you can just console log stuff, see stuff that way. You don't have to like know node or anything like that. It's just a way to run a JavaScript file. So let's take a look at filtering. So if I made a filter, and same thing, maybe it takes an array and a function to apply. I'm going to call it a predicate because that's what it is. It's going to start the same way. I have our transformed array. That's also the thing that we're going to end up returning. I also want to loop through these just like I did before. Let item of array. And now when I call the predicate with the item, it's going to return true or false. What can I do with that?
Would you have, so since it's already a conditional, would you just push it into the transformed array?
Ooh, it's not a conditional. This is either going to be true or false, but you're on the right track.
So if you say, if that item is less, dot, do you have to do dot length?
Oh, so we're not even there yet.
Oh,
We're just
okay.
talking about how the filter works, not even how that predicate function is going to work yet.
Okay.
But you're on the right track. So this is going to, if this is true, then do something. Otherwise, don't do it. So what's the thing we want to happen if it's true?
You want it to be pushed into the new array?
Yes.
Array?
If that's true, push it in. Cool. So now let's go to the next part of this. So we want our predicate function. So we could say like is 4 or less. Some string, and then we can just return whether or not some string dot length is less than or equal to 4. So there's our predicate function. Now, if I want to test this out, I can filter, start with the simple one. Cool. So I'm hoping to see Kyle and Jeff come out of this one. So I'll take in the names, and then I will pass in is 4 or less. And if I run this file, if I run this file, there's Kyle and Jeff. That's what a filter looks like.
So you're doing this because you don't want it all in the same function.
I'm sorry, say that again?
You're doing it because you don't want it all in the same function?
Because the pattern of filtering something, the pattern of mapping something, doesn't have to do with what the actual condition we're filtering on is. Doesn't have to do with the actual transformation we want to do is. You want to split out those two things so that I can do this pattern with any transformation. So I can do this pattern with any condition I might want to filter on.
Ah, okay.
So for example, all right, well, this was just an array of names. Well, never mind. Now we've got this people, and they're in objects, and it's a more complicated thing. So now this is for or less takes in a person, gets their name property, and checks the length of their name. And instead of doing this on names, I do it on people. My is for or less thing, run that the same. And oop, that didn't work. So I'm calling this with people, calling is for or less. My item is person. Oh, it's because I don't have Jeff and stuff in there. So yeah, if I do Jeff and Kelsey, and try running that again, there's Kyle and Jeff. The pattern still works, even though the actual filtering condition is slightly different. That's applicative programming, separating out that pattern from the thing you're doing with the pattern. Ask me some questions about that. Cool. So, you guys want to do a reduce or you want to do like a find or something? Reduce is hard, but I believe in you.
I'm down.
All right. It's one vote.
Reduce.
Yeah.
All right, let's do reduce. So, let's talk about what a reduce is. So, big picture, think to yourself for a second, what does a reduce do? If you had to explain it simply, I'm gonna call on somebody, think to yourself for a sec. Paige, what does reduce do? Give your best shot.
Pick someone else. It does something and returns a single like value. I don't know.
Yes,
I don't know
that's
what it
it.
does.
That's it. So, takes in a collection, returns a single value. That's exactly what it is. So, to refresh ourselves with what this looks like when it's done, we want to pass in some collection. And I wonder if there's a name. If there is, I don't know what it is. This doesn't have a cute one like predicate, or like the one that you pass into a sort is called a comparator. I call this like an accumulator. So we're going to pass in this collection and this function. And so an accumulator, oh, and then there's one other thing that we need. A starting value. So how this accumulator works is it's going to take in the last value and the current value, and it's going to return the new value. So this is the shape of any accumulator. We don't know what this is going to be, but we do know that it's going to have this shape to it. Whoever's using our reduce function is going to write whatever the accumulator is, but we know that it's going to take in this argument. We know that it's going to take in this argument, and we know it's going to return this. So my challenge to you, write the reduce function. How does this get implemented?
So in the body of the accumulator function sits the mathematical operation that you want to do to it, correct?
Exactly, but we don't know what that is. That could be anything. What does the reduce have to do to account for that? Give it your best shot. Go. Another minute? All right. Fist to 5 me. Fist is, I don't know what we're supposed to do. 5 is, I gotta work and reduce. All right. Thank you. Thank you. All right, let's walk through it. So if I'm making a reduce function, that's taking in some collection, some accumulator, and a starting value. So we'll call it array, accumulator function, starting value. All right, any ideas on what I can do next?
You need a result to return, right?
Yeah, it's something like that. Now, like, I could probably do something like return the starting value, and maybe I just mutate the starting value every time. Or I could do something like let result equal starting value, and now I can just call it result. Good first step. What else?
You need to use a loop in there.
Some kind of loop. So I could do like a let item of array. So I'm iterating through each of the things. And then what do I want to do? Think about what the accumulator function's signature is. Whatever the last value is, whatever the current value is, and what I'm going to get back is whatever the new value is.
That's where you'd use the accumulator function.
Because I want to apply this function to everything in the array, each of the items.
So can you just call it there in the loop?
I totally can. So let's take a look at the signature, though. It's taking in 2 arguments. That's a little bit different than before. The last value and the current value. So what gets passed in here?
Would you use results as one of the
Yep.
arguments?
Ding, ding, ding. And
Item.
good. And one last thing. So this is going to end up returning whatever the new value, whatever last value is going to be on the next iteration. So what do I end up doing with this?
Return it?
Do you need an if?
Not quite. Good guess. So this function call here is going to ultimately be what the new value of result should be, like for the next iteration. First iteration. Let's look at this with an actual thing. Let's say we have our thing is called sum. And it takes in sum so far and a number. And then we return the sum so far plus the number. And we've got some numbers. So what we want to do is console log what happens if we reduce some numbers. We're passing in sum as the accumulator function, and our starting value is 0. See if it works. Ta-da! So we'll walk through it step by step. When we call reduce, it gets some numbers, sum, and 0. So array is the accumulator function is sum, starting value is 0. So this starts out as 0. Then our first item is 1. So we're calling our accumulator function with 0 and 1. So sum so far is 0, number is 1. 0 plus 1 is 1. So the result is now 1. But wait, we've got more in this array. So the next item is 2. So now we're passing 1 and 2 in. All right, well, that's sum, so that's 3. Result is now 3. So now we're passing 3 and 3 in there. So now result is 6, and so on. But this pattern, this works with summing numbers. It also works with building new arrays. Anything that follows this pattern of taking a collection of things and boiling it down to one value. That's a reduce. What the boiling is, arbitrary, doesn't matter. That's applicative programming. Ask me some questions about it.
It's kind of crazy seeing the variable result on line 8 like twice with it in there, but I guess.
Which line number? You mean on this one?
Yeah.
So
yeah.
think of it this way. This gets evaluated first, and then the result of that gets assigned to that. Here's another way you could think of that. What if I did that? That's the exact same thing.
Yeah, that makes more sense in my brain.
Cool. If it helps, use it.
Cool.
Also, anytime you see this pattern in code, where you have that and they're kind of like at that diagonal, that's like cross cancellation in math. Anytime you see that, you can just do that instead. They're the same thing.
Hey, can you say that one more time, please?
Yeah. Do which?
What you just
Cross
said?
cancellation thing?
Yeah.
So if I see that at the beginning, so I'm assigning something to that, and then I'm using that assignment here, it kind of makes a little like diagonal line there.
I see.
It's just like cross cancellation and like multiplying fractions and shit. That means that that's the same thing. Or like more literally, new result is this. So use new result. All right, well, that means I can just, that means those are the same thing. So I can just use it that way instead.
So the accumulator function has two parameters, result and item.
Mm-hmm. The accumulator, that's what I'm passing into it.
Okay, that's what you're passing into it. And where does that come from? Or are you creating something new?
So those are what I'm passing in to sum. So I could also say, like, result is the sum so far, and item is the number. So result was my starting value, which was 0. So the first time through this, result is 0, item is 1, because it's the first thing in this array that we're applying the function to. So the accumulator function is always going to be sum for like this call, because that's what we passed in. So I'm calling sum with 0 and 1. That's all that's happening the first time through on this line.
So your accumulated function is just your outside function?
Yep. Just this guy right here.
Ah, okay.
But it doesn't have to be sum. It could be divide. It could be give me like everybody's names. So like let's say that I take this people thing and I write a function that takes in like a list of names and a person and adds that person's name to the list. So like add to list of people.
Mhm.
And so I take in an existing like string of people and a person. And then I return whatever string of people is right now with a comma after it, and then person.name. That's an accumulator function. So now I can take people, add to list of people, and start with an empty string. It's going to start with a comma. It'll be a little weird, but oops, something goofy happened there. Everybody showed up twice, but that's the gist of it. That's also a reduce.
Okay.
Anything where we're gradually accumulating has this exact same shape to it. So what the actual accumulation is can be separated out from it. Just like a map is transforming everything in an array. What the transformation is, that could be anything. Filtering is taking a list of things and maybe not keeping all of them. Why we choose to keep something or not, totally separate from the shape of filtering something. Accumulating something is totally separate from what and how we're accumulating it. Ta-da!
So this is what happens every time you call a reduce function.
Correct.
Okay. I guess I like completely understand. I just am having trouble like picturing how, because like when I pass the like when I have a reduce function and I make an accumulator, I'm not passing in the mathematical operation into the accumulator. It just kind of sees how it interacts with like the number and the accumulator and then puts it in for accumulator.
No, it's the same thing. If I'm writing this in regular JavaScript, I might write it something like I might write it like that in regular JavaScript, but guess what this is? That's a function. And that's a starting value. It got the numbers
Yeah, I see. Okay.
through like a little bit of JS magic, but if I decided that, yeah, you know what? Fuck it. I don't like JavaScript's built-in reduce. It sucks. I can completely overwrite it by changing that to this, like self in Ruby, and saying array.prototype.reduce is reduce. And now it's using my reduce instead. More questions about this?
So in applicative programming practices, you always want to separate it out like that and not use an anonymous function within, so that you can reuse it for other purposes.
Exactly. Now, like in practice, I pretty much always start out by writing it this way, and then I extract it out. So that it eventually just becomes that. And really, what's way more common in functional programming is not using these built-in ones at all to actually do separate functions like I did up here. The real functional way to do it would be say like sum all is reduce sum 0, and then the data gets applied to that separately. Like that. Or there's that cross cancellation thing again. That's the actual way to like do that in FP. If that just exploded your brain, don't worry about it. It's not important. But yeah, the inline anonymous functions, like there's an exception, but otherwise you try to stay away from them like in the code that you're keeping in functional programming. Other questions? So our goal is to be able to code an applicative function. Sounds like we're a little hit or miss on that. And in case you didn't pick up on this, this is really advanced stuff. Like, this is like going down the JavaScript well a little bit. But hopefully it's giving you an idea of like how some of the things that you've been doing since literally day 2 of the program, what these look like under the hood, and how you can use these ideas of separating out the pattern of something from what the actual thing is, that's where programming gets maximum powerful. So hopefully you at least had something worthwhile you took out of this, and I hope you have a great lunch.
Thanks, Kyle.
This broke my brain, but thank you.
Very welcome.